Arno Amberla to the stage. He's VP Technology at Proventia. There he is. Thank you for joining us. Arno's going to give us a presentation on the trends in after-treatment technology choice for in-use vehicles, which is covering retrofit after-treatment systems for on-road vehicles and some of the related opportunities there. This is something which I think is important for addressing air quality. We heard from Finn from Transport for London yesterday about how important this is. Arno joined Proventia in 2002. Recently, he's been responsible for stage 5 emissions control technology, that's for non-road applications, and retrofit system developments to reach Euro 6 in on-road trucks and buses. As I said earlier, Euro 4 and 5 vehicles often have quite poor performance, so Euro 6 is often seen as a solution to a retrofit solution. So Arno, over to you. We look forward to seeing what you can offer. Thank you.
Good morning, ladies and gentlemen. Today I will be talking more on heavy-duty vehicles rather than passenger cars, because passenger car retrofitting from our point of view is not very feasible because of the cost factor what is on the system. Outline of my presentation, going through a little bit of background, lessons learned, and monitoring system, how we can make sure that the systems are really working once they are installed, and some ideas that what's going to happen on the AdBlue consumption. Proventia, we have been on the business for more than 20 years. Our main business is emission control for OEMs and retrofits, and the knowledge we have for retrofit is originating from OEM customers, OEM applications, where we are supplying complete after-treatment systems on stage 3B, 4 and 5, so non-road mobile machinery. And then we are also doing test solutions to test and validate our systems in a container-sized test units. Our vision is zero emission, and in this case it means zero tailpipe emission. That is something which is not the reality at the moment, but this is one of the steps towards the target. On Proventia's history, we have done a lot of retrofits starting 2002. At that time, we were named as Fincatalyt, and very steep growth since 2015, including all these business areas. And retrofit has been since 2012 focusing on SCR retrofits. As we have seen over these days, the air quality in urban areas is the problem, and especially direct NO2 from tailpipe emissions is one of the big contributors to ambient NO2 level. Older diesel vehicles and machines, they are the worst polluters, and what we have seen over these days is that Euro 6 is clean, also in passenger cars as well on heavy duty. But as the population of Euro 6 is not that high at the moment, there's also another way how to improve the air quality by retrofitting those existing vehicles which are on operation. Retrofitting gives cost-effective way to reduce the emissions from existing fleet. Buses' typical lifetime is 15 years, and Euro 6 has been on operation only for last 5 years. The trend in real drive emissions, and this is from city buses, has been nice from Euro 1 to Euro 3, but then the real drive emissions, real world emissions have been more or less stable. And Euro 3, 4, 5, EEV, they are all about on the same level when it comes to real drive emissions. Especially on the 2-axle models which have less load on the engine, less temperature, the SCR is not functioning on real city operation. On 3-axle, the trend has been a little bit better The emissions are slightly better in terms of grams per kilometer, but still the trend is not following the regulations. And surprisingly, diesel EEVs have worse emissions than Euro 5s. They should be on the same level in NOx. Gas engines are also on the same category with the diesels, so no significant improvement on emissions. But Euro 6, that has been a step towards lower emissions, and one of the big things has been the test cycle, including the cold start, and because of that, because of change of test cycle, the low temperature operation has been more effective for SCR. With retrofitting, we are able to bring Euro 4, 5 and EEV vehicles on the same emission level as Euro 6, or in sometimes even lower level. Here is examples of NOx emissions from different vehicles, including passenger cars, as well diesel buses, and the limits for passenger cars. These are all grams per kilometer. So passenger cars, this is limits from the regulations, but diesel buses, these are real-world emissions as they are expressed in grams per kilometers. The worst case applications, they are really far from the limits. Euro 5 bus, a typical bus, is almost on the comparable level as a worst case Euro 5 passenger car. But when we look at the worst case diesel Euro 5 buses, they are absolutely terrible. Not just the NOx, but also the NO2, direct NO2 fraction can be 20 to 50%. And if the SCR is dead in terms of catalytic activity, the ammonia slip can be hundreds of ppms. Dosing takes place, nothing happens in the catalyst, emissions are high. And the direct NO2, which is on the right-hand side, is the most critical in ambient air quality. Diesel Euro 6 buses on typical level, they are okay. We have not seen any dramatic worst case Euro 6 bus if they are on normal running conditions and done the maintenance what is needed. This kind of NOx Buster City DPF plus SCR is the retrofit system which replaces the original Euro 5 system. So we take away the Euro 4 or 5 SCR system or whatever after treatment there is and install DPF plus SCR, including tanks, pumps, driver display, or we connect on the engine and vehicle CAN bus so that the original urea level is indicated on the dashboard, including a little bit of extra sensors to control the system. And we are able also with the ProCare Drive monitoring system have full transparency on the emissions, send it to the cloud. And for example, Transport for London requires this kind of telematics, and we are able to see how the buses are operating in real drive, second by second. Couple of examples from World Harmonized Vehicle Cycle. This is done on chassis dyno, converted into grams per kilowatt hour by knowing the work over the cycle. And we can see that 96% NOx reduction over the standard system. This is not saying that the Volvo system is bad, but it is completely different test cycle what was used on Euro 5 limit. So don't take this as a complaint against Volvo. They are just what they are, completely different test cycles. And AdBlue consumption is roughly 3 to 5% of fuel consumption. In other words, it means that we are consuming some 2-3 liters of AdBlue per 100 kilometers. Similar results from EGR-equipped Scanias, 92% reduction meeting Euro 6 limit, including again the cold start emission. This has been also tested on PEMS, Euro 6 method, city bus cycle, and conformity factor of 0.36, so there is reasonable safety margin against the limits. To make a retrofit system work well, one key thing is SCR chemistry, so that it really is designed for low temperature operation on what is taking place on city operation. Average speeds can be very low. In London, they are 10 kilometers per hour, and in many other cities, they are 20 kilometers per hour. Another thing is that the system has to fit on existing space without modifications on the bus chassis or body of the vehicle. And then the SCR dosing and calibration, we have to be very precise, dosing control, when to dose, so that we are not getting blockage because of deposits, and we are utilizing the whole AdBlue for SCR reactions. OBD requirements in this project require that we have power derating if our system is not working for any reason, or if there is no AdBlue on the tank, and therefore we have to go a little bit on the engine ECU, so that we are sending the messages that the derating is required if the system is not working. And because of the low temperature and low operation speed, thermal insulation is needed on the system, but also on the connection pipes. Otherwise, we are losing some decrease of temperature, and then we are in trouble, and we cannot have the full chemistry operating in the system. We had a presentation yesterday from Fincoil, and I can also say that London has been a success case in terms of retrofit project. They have set clear targets. They have said that 5,000 buses are going to be retrofitted. They have clear deadlines to comply with, and they have the whole process, including supplier audit, emission testing, installation, and after-sales support is included in the package. So from the first day until the system is working and until the system is working for 5 years or more. In this case, the emission testing includes detailed test procedure. They have chosen a Millbrook bus cycle, including NO2 limits, grams per kilometers, ammonia slip, which is the same as Euro 6 standard has, particulate mass and number limits, and they have also the secondary emissions of CO2 equivalent from N2O and methane. There were some questions yesterday and discussion if Euro 6 standard systems are complying with the same 5% CO2 equivalent. I don't have data on that, but the 5% increase is what we have to comply. And we know that some vehicles are having already from engine out baseline a bit of CO2 equivalent components even before any catalyst, and that could overshoot us from the 5%. Fuel consumption in terms of CO2 increase cannot be more than 1% within test repeatability. This project is ongoing, and based on data from yesterday, about 1,000 pieces has been now installed up and running. In Germany, city bus retrofit project is starting. emission performance criteria is minus 85% based on PEMS measurements. So we have to do PEMS measurement before and after retrofit system. And there is a special requirement that the system has to have 85% NOx reduction at -7. And that is something what we have to prove. During summertime, it's a bit difficult, so we have to do PEMS testing also during cold ambient conditions. In Sweden, there's retrofit project and regulation. The testing is based loosely on UN ECE Reg 132, but allows chassis testing. As we know, all the retrofitted vehicles, they are vehicles, not loose engines, and therefore testing on chassis dyno is accepted. This regulation in Sweden covers heavy-duty vehicles and also trucks, not just buses. There's also Euro 6 retrofit regulation in place in Denmark, and limit is to reach Euro 6. From retrofit point of view, it's crucial to have single point of contact regarding approval. Otherwise, we could get different messages on different technical questions. As in London, transparency of emission performance in real driving is needed. We have to have telemetry in each and every vehicle to see how they are working, and we can alert operator that something is wrong if something is really wrong. And there has to be clearly specified test methods and limits to be feasible project. And there can be also some scaling. If we have to do test for each vehicle type, that increases our test cost and doesn't make sense. But then we have to do engine families or groups so that we test worst case, for example, from certain vehicle category, the highest power and the lowest power, and we can scale the system within those limits. Few words on online emission monitoring. We have this ProCare Drive emission monitoring system giving real-time emission data to operators and city-level organizations. This is based on vehicle signals from sensors. There is some discussion if the sensors are showing correct values, and a few words on that. This is how the monitoring system looks like. On the left top corner you see reductions over 1 hour average. Then on the top picture you see NOx in, NOx out, temperatures, back pressure and speed profile over a certain period of time. And with raw data you can go on second by second data to see how they are working there, to see if there is a peaks during acceleration or some peaks because of braking. And it's even possible to then put it on the map to see that if there's a peak coming, is it at the bus stop or next to the bus stop. So the emission originated in city can be put on the map that this bus has created this much of emissions on this spot of the city. Example of how the data looks like. This is original Euro 6 and not retrofitted one. We can see that there are NOx peaks coming from the system with temperature 220, 260. But once the temperature goes more than 250, the NO is really low. No issues on emission performance. But some difficulty at temperature range 220, 260 degrees C. Same route, same day, retrofitted Euro 6 vehicle, we can see that temperature has dropped down because of longer idle period below 200 degrees C, and after that we have a short peak of NOx coming from the system. But once the temperature is more than 220 degrees C, NOx out levels, they are really low. The accuracy of this telemetry system is related on NOx sensor characteristics, both the location where it's located in the exhaust pipe, cross sensitivity to other components like ammonia, and it requires the minimum temperature so to be able to read NOx. There might be also some errors in exhaust mass flow calculation if it's taking with a sensor or if it's taking from engine CAN bus information. And if the distance signal is taken from GPS, there could be some missing signals on narrow street corridors. In general, we see that less error when the emissions are high and more relative error when emissions are low. And always this telemetry system shows worse results than real emissions. And in real emission, I mean PEMS or chassis testing. So we are, in that sense, we are on the safe side. And anyway, it gives a good picture of fleet emission performance. It's easy to track the worst ones, which are really the problem one. And we are checking that how to increase the accuracy of the system. And one thing is the NOx sensor. So after warm-up, it has been seen that the NOx sensors can be oversensitive. There are some small peaks in level of 10 ppm, but from PEMS or other standardized methods, there are no NOx peaks coming from the system. So once the NOx sensor has just warmed up, there is risk that it is oversensitive to some component and gives a little bit of readings. At the moment, as we know, the standard Euro 4/5 vehicles, they have about 2 to 3% AdBlue consumption compared to fuel consumption. When we are retrofitting this to Euro 6 level, it increases AdBlue consumption up to about 5% of fuel consumption. But what we see also from Euro 4 and 5 vehicles is that some vehicles are already now having reduced consumption. Either the systems are faulty and they are not dosing on the level what they should, and also higher emissions because of that. And some part is because SCR systems have been manipulated, AdBlue off devices or that kind of manipulation devices. Our estimation on number of manipulated systems increases from buses to coaches to trucks. So the buses which are operating on city level, now estimation is less than 10%, from coaches less than 25%, but 20 to 50% of trucks are somehow either being manipulated or not just working for other reasons, faulty systems. And this estimation covers Euro 4 and 5. When we do a retrofit project locally, they are locally focused. Magnitude is a little bit small compared to new heavy vehicle sales or truck operations, but in those retrofit areas and low emission zones, AdBlue consumption increases. And one reason is that after this retrofitting, all Euro 4 and 5 diesel buses are using AdBlue, also those which were originally EGR equipped. Thank you.